All right, people are starting to quiet down, so I guess that's my cue to get started. My name is Ryan Schoen. I'm a product manager on Chrome on working on performance, so it's probably appropriate that I'll be running the lightning talks this morning. You may have saw my email go out on BlinkDev, but the idea is to give anyone who's interested a chance to talk about what they're excited about or what they're passionate about for 2 minutes here. I've had several people send me emails or send me slides saying that they wanted to do a lightning talk, but I want to encourage you, even if you didn't tell me, if you have something you want to talk about, or if you're sitting there and you get inspired by one of the talks and want to do one talk of your own, feel free to do that. So I'll ask anyone who's interested to do a lightning talk to just start lining up on the left over here, and we'll get going. And we will start, though, with the people who gave me slides, because that is just logistically challenging to switch out. So I think I wanted to start with, where'd he go? Kentaro. Yes. Ah, yes, okay. So you're up first. Go ahead.
Okay, so I'm Hara from Tokyo. So today I would like to introduce the awesome work in First Atom team in Tokyo. So in the First Atom team in Tokyo, we are doing a couple of projects. So regarding OilPan and BlinkOn.js, we are going to have a session tomorrow, so please come to the session. And in this talk, I would like to introduce the other projects. So we are doing core module componentization. So our goal is to make core modules and web separately buildable. So currently there is a dependency, so bidirectional dependency between core and modules. So everything is linked into one shared library. So we are going to break the dependency from core to modules and make core modules and web separately buildable. And we are also planning to move more things from core to modules, including storage, streams, timing, accessibility, clipboard, plugins, workers, and XML. So the benefits of doing this is we can speed up build time, and we can also improve hackability of the code base. Another thing we are doing is improving code health of V8 bindings. So our goal is to make all DOM objects derive script wrappable and thus remove unnecessary code from the code base. And we actually removed 80,000 lines of code from auto-generated code. So because we have 800 IDL files, so we removed 100 lines from each generated bindings for each IDL file, which means that we removed 80,000 lines of code from auto-generated code. And we also removed custom bindings for array buffer and typed array, which means that we removed 2,000 lines of code. And we are planning to remove more. And another thing is web IDL conformance. So we are improving the IDL compiler to make it more conformant with the web IDL spec. So we implemented overloading resolution algorithm, and we are implementing IDL dictionary, which is used by service worker, geolocation, web animations, web crypto, and a lot of modern features. And we are also implementing IDL union type, which is frequently used by service worker. So we can now use double or string or blob or file. Yeah, that's it.
Great, thank you. And the one thing I should have mentioned is if you do hear something that excites you or you're interested in, you should tell the speaker about that and tell them to do a breakout session sometime during the conference. We still have lots of room left. Next up.
Hi, I'm Kouhei, and I'm starting to work on better content mode. So currently, we are rather focusing on PLT, but I'd like to focus more on visually instant and responsiveness of content mode. So content modes should be always visually instant, so that user should not wait staring at blank white page while loading page. I think this was also mentioned in the first session that we should load everything within 1 second. We should display something within 1 second, and users should be able to interact with the web page after the 1 second. So I'm starting some work in this area. first thing I did was to enable background parsing for all asynchronous parsing. So it was already enabled for main resource loading. That is the main HTML file since M28. But I now enabled it for all cases, including XML, HTTP requests, HTML imports, and other HTML parser involving stuff. I'm currently working on making HTML parser work as Blink scheduler, so that the parser tasks are scheduled in right priorities. So this should make the first thing faster than we are previously doing, and this should also prevent HTML parser from janking animations or keeping user input responsive. So the implementation is still work in progress, and I've written a design arc. I think this slide will be shared later so that you can actually click on this link. And this is more speculative work ideas I currently have. So the currently, in order to parse something asynchronously, you have to use XHL or use an iframe or something. But this is within an old API. So we are creating a spec on Fetch API. But after Fetch API, we have no way to do the streaming parsing. So I'd like to propose a streaming HTML parser API so that we can continue streaming parsing after the Fetch API goals. Also, I'd like to improve HTML tree loader that is a massive set of if statements that can be made much faster. Also, I'm trying to doing something post parsing that asynchronous style we call create and paint, but it's still in exploratory phase. So if you're interested in those topics, come talk to me, please. Thank you.
Great, thanks. Next up, we have Sami talking about best effort sync scrolling.
Hey, so my name's Sami, and I just wanted to give a quick spiel about this small feature that we shipped in M38, I think. Not really a feature, but more of a scheduling tweak, and it's called best effort sync scrolling. And essentially what it lets you do is let the main thread in Blink react to composited scrolling updates within the same frame as the compositor itself. So for instance, you can have your own scroll handler, mutate the DOM, move stuff around and have it appear in a consistent place with the compositor scrolling offset. And you can use this to implement things like hidey bars or pull to refresh and all this fancy UX that we were talking about. And so let me show you how it works. Previously, what we used to do with compositor scrolling, first you do the scroll update on the impl thread, which means just moving layers around. And immediately after that, you do the composite, which draws the result of the new layer layout. And in parallel to that, you tell the main thread about the new scroll offset. So this basically meant that you always are at least one frame behind the impl thread, so you can't do this synchronization. And the way we fixed it is we introduced this deadline here. Essentially, we do the scroll update on the impl thread, then we tell the main thread about it and give you a little bit of time to react to that. And if you're quick enough and get back to us within the deadline, then you can still make the same frame and everything's nice and synchronized. And this also explains the name. It's still best effort, so it's not always guaranteed that you'll make this deadline, but most of the time it works. And if you're bothered about the fact that it's best effort, you should come to Tim's and Rick's talk tomorrow about a really guaranteed way of doing this same thing. That's it.
Thank you. Next up, Brandon's going to talk to us about VR.
Yeah, so I'm talking about something that's really, really experimental right now, and that's getting input from VR devices like the Oculus Rift or this guy, Google Cardboard, into Chrome. This is an effort that I've been undergoing with developers from Mozilla, so we're both collaborating on the API. And at the moment, it's only available through developer builds that we've put out on our personal websites. You can get to that through a website, webvr.info, which may or may not have actually propagated to your DNS because I just bought it this morning. But we needed a simple thing that you guys could remember. WebVR is all about making sure that this next upcoming generation of devices that allow for virtual reality have a very easy way of getting input and output through a web page, through JavaScript. So exposing orientation info to the JavaScript API and then giving you all the metrics that you need to be able to render the stereoscopic image back to the headset in a very easy way. Like I said, it is very experimental. It's not in the Chrome trunk yet. Hopefully it will be, but that depends very much on developer interest and where the hardware goes. But if you're interested in learning more about this, or you want to experiment with the builds that are already there, once again, webvr.info, and you can come find me anytime during the conference. Thank you.
Hi, I'm Paul. This is Andrey, better known as CaseQ, typically. And this morning we heard, about performance, how it's a big priority for us, and how it's a big priority for helping our users and web developers understand what they can do to make things fast. So we wanted to show a little bit of what's happening inside of the DevTools to improve this story. Yeah. So let's start.
Okay, so there used to be some concerns that recording timeline basically skews the page and basically skews the performance results. So we're doing something to address that. We're moving the instrumentation that, basically the handcrafted instrumentation that we used to have to trace events. And there's still potentially some skew, but it's much better controllable. It's much smaller also. And it is now also much easier to add your own type of events. You still need to dig into front-end code, but it's essentially a couple of lines. And we're also disabling all other DevTools agents for the time of recording timelines. So we're disabling DOM agent, debugger. They used to produce some interferences into results that we measured. And you can also select what type of events you record. You can individually control stack, paint stuff that we will talk about later. So that makes it a bit easier to record the precise timings.
Yeah. In addition to the improvements on the accuracy side, we found a nice way to integrate kind of what's happening inside of V8. Many times as doing a recording, you see you have a lot of time spent in scripts, and you have to hop over to the JavaScript profiler. Here we kind of show a kind of condensed view, and this is the new flame chart view of the timeline, where you can kind of see both things like parse HTML, style recalc, layout, in addition to the actual call frames from the JavaScript. So a nice full integrated view of everything that's happening.
And this is, by the way, now default. So we still keep the old waterfall view, but this one will show up by default.
Yeah, pro tip on walking around in this. Just like tracing, you can use WASD to kind of zoom around and move around inside of this view. And you can also box select a certain visible area with shift drag. Kind of pro tips where you're making that easier at the same time. What's the red triangle? The red triangle.
It's a warning.
Yeah, it's a warning. In this case, it's like for style recalc. Yeah.
So yeah, we're trying to sort of do a runtime audit of stuff you do, and if something appears suspicious with the red warning, it's actually just for a couple of events so far. But the idea is, like Dmitry mentioned on previous talk, that if user is doing something wrong, we want to be pretty explicit about that.
Yeah, so we can like expose the deadline that Sami just mentioned similarly.
Okay, and we also integrate the frame viewer into timeline now. It's pretty similar to the one that you used to see in tracing, but we've basically re-implemented the UI. So here is a small demo of that. So you can see the verge, and you can see a lot of green on the timeline, which means it spends a lot of time painting. So let's select a few frames. Let's pick this frame, for example. You can see the paints on the layer 3. You can basically zoom it, rotate, and you can double click the paint to see the paint profile. And interesting stuff here, you can, yeah, thanks. You can see that most operations are really cheap, but there are a couple of outliers. And if you select them, it's not what you expect, probably. It's not even an image, it's draw path. And if you right click and reveal an elements panel, it will actually navigate to the particular element that was being painted. And you can see the box shadow here. Thanks.
Yep, so we're excited about this. One thing also we want to call out, PDR and Kouhei, who's just up here, have doing some fantastic work in invalidation tracking. So from style recalc to paint, to layout to paint, you kind of see the invalidations that led to this specific operation. So on this paint, we're seeing that is forced by a few different things. Walk back on whether this was caused by an animation, a specific JavaScript call stack, but we get a lot more insight into why exactly this paint just happened, which is fantastic. So you can turn this on with the little causes checkbox at the top, but we're really excited about this. And I think that's it for us. Thank you very much. Appreciate it.
Thank you.
I guess you had two people, so I won't yell at you for going over 2 minutes. Next up, Joel's going to give us an update on security.
Hey, everybody. I'm Joel, JWW. And yeah, I'm from the Chrome security team. And I thought I'd give a quick update on some of the things that we've been working on and things that have been happening, but I'll try to keep it pretty brief. The biggest thing and most relevant to most of you probably is actually site isolation, but I won't be talking about that today because there's a whole talk on it tomorrow at 4:15 from Daniel Chang. So you should go to that if you think that's relevant to you or interesting, and it's going to be super cool. So from the Chrome security team's perspective, a lot of really great stuff's been happening. We've been doing a lot of content security policy work. A lot of fixes have been going out, especially with regards to isolated worlds and making sure we're sort of behaving consistently and how developers would expect it to work with isolated worlds. Also really big and cool, content security policy 1.1 is out from behind a flag. It's now part of the code and it's being used a lot, and it's really exciting. We also have a cool new feature called sub-resource integrity that's being developed, which allows you, I sort of give a partial talk about it at the last BlinkOn. Basically, it allows developers to provide a hash and integrity value for a resource they want to load. And we're sort of working with on the W3C to standardize this and come up with a standard, but we actually have an implementation behind a flag for scripts and styles. So we're right now seeing how useful it is for developers and see if it's useful and interesting for developers. We also have another thing I talked about last time is this concept of sub-origins, which is another way of namespacing origins and separating origins into multiple namespaces. We have an implementation underway. We're starting to work on a proposed standard for that as well. We did a lot of work with the service workers team, and I'm really excited. Everybody, I'm sure we're going to hear about that later, and lots of really cool stuff there. And we did a lot of work with them to make sure that it's a really cool, secure technology that's going to be in Blink. And then sort of the last big thing that we've been doing some focus on is sort of a general thing with Chromium has been trying to move the web towards HTTPS, but also trying to make sure that you know the things that we create in the future and going forward, that if they have any sort of real sensitive or potentially dangerous part to them that we don't want bad guys to be dealing with, we want to make sure that they're almost always and you know by default available over HTTPS only. And so we actually have an implementation out that a lot of people have been using to make sure that for new features we're checking to make sure that it's being executed on a secure origin, and that's sort of the default now going forward. But sort of the next thing we got to do is we have to start making sure that the top level context is also HTTPS. Otherwise, it's sort of completely irrelevant, because then you can simply bypass it by having your top level HTTP context talk to an inner HTTPS context. So anyways, that's a really quick whirlwind overview of some of the things security's been looking at and working on. If you have any security questions or want to talk about security stuff, JWW, I love talking, so yeah, just let me know. Thanks.
Thanks, Joel. Next up, Matt's going to tell us about the media source API.
Thank you. So I'll keep this very quick. I'm Matt Wolenetz. I work on Chrome and Blink implementation of media source. And I don't know if you remember from the state of Blink, it was one of those bullets that we unshipped the prefixed implementation. And right now we're closing in on completing the compliant implementation of that API. So if you have any questions about media source, it's essentially an ability to, or it enables adaptive streaming and splicing of media behind the video tag. Come see me, and I'd be happy to talk to you about it.
Our queue of people is drying up, so if you do want to do a lightning talk, make sure you're over here before I close the session. Next up, Tim is going to talk to us about style, I assume. CSS parsing, yes.
All right, hello, I'm Tim Lowe. So I've been working on the CSS Parser lately. Basically, the project is to build a spec-compliant CSS Parser. Tab's been working, or has probably finished, the CSS syntax module level 3 spec, which defines how to tokenize and parse CSS. Axel and Yov have done some initial work in implementing the CSS tokenizer a while back, and it's mostly finished now. And a few months from now, what we'll do is we'll get rid of the existing Bison parser and we'll replace with this new one. Hopefully, it'll do things like be faster, and it should allow implementation of CSS variables. So if you remember, we removed that from Blink maybe like a year ago or so. So that's one of the things that will be coming back once the parser rewrite's done. All right, thanks.
Next up, Anton's going to talk to us about presentation API. I can keep all these straight, I swear.
Hi, my name is Anton. I'm part of a London team that works on Chrome for Android. And I'm also a member of a second screen presentation working group. So I'm implementing the presentation API in Blink and also in Chrome for Android. So the API kind of allows the web pages to present content on second screens, which are any screens that are capable of showing something that are connected to your device via a cable, like HDMI, for example, or wirelessly, or somehow else, maybe through the cloud. So it's a pretty simple API that shaped very similarly to just opening a window on a second screen. And then it allows the web page to communicate with like another page loaded on the screen. So we just made it to a working group from a community group this month. Yeah, so if you have any questions or thoughts or feedback around the API or implementing it, please talk to me. I also worked on Chromecast support and Chrome for Android, so if you have questions around that, you can feel free to talk to me too. Thank you.
Thanks. And potentially last up, we have Rick, who tried to explain to me what he was going to be presenting on, and I didn't get it. So,
hi, I'm Rick. I'm here because I'm pissed off. If you know me, I'm usually pretty happy, but I'm actually really pissed off right now. And I'm pissed off because I screwed up. And I screwed up by, ever since I've worked on input, I've worked on rendering. And there's a common theme of bugs that I've hit over and over and again. And that's where I wrote some code and I used an int point or a float rect. And I thought that was in one coordinate space, but it was really in another coordinate space. And something was subtly wrong because I was using the wrong coordinate space. And ever since that first happened, I thought, oh, we should fix this. We could fix this. Like, why don't we fix this? And I kept putting it off and putting it off and putting it off. And it finally happened. I shipped a nasty regression. We didn't catch it in beta. There's a subtle regression where if you tap on things, the mouse event coordinates are sent with the scroll offset incorrectly applied. And that made it to stable. And I'm really pissed off about that because it broke some real websites. So this is not okay. It's time to fix this in the code. There's a bunch of guys that are working on fixing this. I actually haven't done anything myself yet, but the guys that are actually fixing it are either too chicken to stand up here or too surprisingly just hoarse for one reason, or they forgot their passport, so aren't here. So I'm going to tell you about it instead. But the idea is make a type system for coordinate spaces. So you could have, instead of just endpoint, you could have a window endpoint or a screen endpoint or a layer endpoint that's relative to some specific layer. And if you try to assign it to something that expects an endpoint for a different layer, you'll get a debug check. You know, we can debate about what to do in release builds. We don't want any overhead in this, but at the very least, you should have compile time errors and maybe asserts that tell you when your coordinate systems are mismatched. And doing this incrementally is going to be a little challenging because you might have noticed if you've ever worked in Blink, there's a couple endpoints, there's a couple coordinates sprinkled around the code base. But we think that there's a practical way to roll this out incrementally and just push the coordinate space system throughout Blink more and more to make these kind of bugs, to make the compiler in our assert system actually catch these things so that I'm not so pissed off anymore. That's it.
Okay, thanks, Rick. Last call. Anyone want to do a lightning talk? Yes. All right.
Yeah, hi. I'm Philip. I'm holding the debugging session at 3:30, and that is incredibly vague. So I don't want to tell you what that's about. I've also made bugs, and then I got assigned to fix these. And I don't even know how to fix bugs. So I suggested let's have a session about it. Let's talk about that. And I didn't even volunteer, but then I was volunteered. So if you know how to fix bugs, or you have if you really want to know how to fix bugs, come there. Maybe someone will tell us. So yeah, this is just a warning that I'm not presenting a new tool or a new solution to the problem. It's more about identifying what the common pain points are, because we all spend, I don't know, maybe 20–50% of our time debugging, and it's not something we talk a lot about. So let's talk about that.
At least one more talk. Tom's going to talk about Skia.
Nope. I'm Tom, and I don't even work on Blink anymore, but I'm going to get pissed off about something related to what Rick was pissed off about and do even less to fix it. The last set of bugs that I was dealing with when I was working on Blink was very closely related to that. We have these things called layout units, which are great for knowing what you're doing and keeping track of the fact that this is really layout and it's its own coordinate system. But there's lots of math overrides and lots of low-level tiny functions that we've declared because we're great object-oriented programmers. And because we think about performance a little bit once in a while, we declare them all inline. And that sort of works until you get to Android, where we also care about space. And the compiler says, you don't really want to inline that. And so 10% of Blink's time was being spent calling into these little functions for units. So when you're thinking about making all of your coordinate systems work well together, or anything else that involves adding lots more low-level tiny functions to Blink, and you think you're going to inline something and the compiler is going to do what you want, think twice.
I like this has changed from lightning talks to soapboxing. To probably not change that, Nat is going to talk to us about something.
I'm grateful to be in front of y'all. I'm known for my gentle opinions. Actually, I was curious, does anybody know how many CSS properties there are? Elliot. Non-prefixed. Oh. Yeah, it's like 400 some. And I think if you look at like the number that people really use, it's like in a mobile app, it's something like 100 some odd. I've used the number 115 a couple times. How many are fast? 3. Not 42. We should fix that. That's it.